Welcome back. In the first part, we explored how to create methods, how parameters work, and how C# structures its logic. Now in part 2, we're going even deeper into method bodies, method invocation, console input and output, and C#'s powerful math library. Let's dive right in. It's important to understand the difference between a parameter and an argument. A parameter is a variable you declare in the method definition, like int a, int b. An argument is the actual value you pass when you call the method, like print sum 510. So parameters are placeholders. Arguments are real values. Matching the correct types and order between parameters and arguments is crucial for your program to work correctly. Now let's look at how we define a method that returns a result. This example shows a method called calculate miles per gallon. It takes two parameters, miles traveled, an integer representing how many miles the vehicle traveled, and gallons used, a double representing how much fuel was consumed. The method divides the miles by the gallons and returns the result as a double. Notice how the method is marked public static double. Public means it's accessible from anywhere. Static means it belongs to the class, not an object. Double means it returns a decimal number result. Methods like this are the building blocks of practical real-world applications. Now, how do we actually use that method we just created? We simply call it by using its name and passing the right arguments inside parentheses. In this example, we call calculate miles per gallon 289 12.2, meaning 289 miles traveled and 12.2 gallons used. The result is then formatted nicely to two decimal places using the N2 format specifier in WriteLine. Always remember, defining a method is only half the story. Calling it correctly with the right arguments is the second crucial half. Not all methods need to receive parameters. Sometimes you just want a method to perform a task without requiring any external information. In that case, you leave the parentheses empty. This example shows a method called displayMessage that simply prints a few words to the console. Also notice, if a method doesn't return a value, it's declared with void, and the return statement at the end is optional for void methods. It's often omitted for cleaner code. To summarize optional parameters, methods can be designed to work without any inputs if none are needed. The method still uses empty parentheses to indicate it accepts no arguments. In our example, the method displays a full sentence in pieces, combining multiple write and WriteLine calls. This might seem simple, but mastering these basics is critical. Understanding when your methods need parameters, and when they don't, is key to designing clean, efficient programs. The body of a method is where the action happens. It's enclosed in curly braces and contains statements like declarations, calculations, loops, and returns. This example shows a simple add numbers method. It declares a variable result, adds the two parameters a and b, and then returns the result. The method body defines what the method actually does when it's called. Once a method is defined, we need to actually call it to execute its behavior. Calling a method means writing its name, followed by parentheses containing any necessary arguments. For example, myObject, displayMessage. Here, displayMessage is a method inside the object myObject. In C#, the flow is always define the method once, then call it as many times as you need. C# offers a huge standard library with predefined methods, ready for you to use without writing everything from scratch. One of the most common classes is console, part of the system namespace. With console, you can write output, read input, and control the user's interaction with the terminal easily. Examples include write, WriteLine, read, and readline. This library saves you hours of work by handling all the low-level input and output operations for you. Let's look a bit deeper into console methods. Write outputs text, but does not add a new line afterward. WriteLine outputs text and adds a new line automatically. Read reads a single character input and returns its ASCII numeric value. Important to remember, read is not overloaded. It always reads a character as an integer. These are the fundamental tools to interact with users. Here's an example using read. We prompt the user to enter a character. Then we store their input using read, which gives us the ASCII value of the character. Finally, we print that value back to the console. For example, if the user types A, the program prints 97, which is the ASCII code for the character A. Now sometimes you want to see the character itself instead of its numeric ASCII code. In that case, you simply cast the result from read into a char type, like this, char read. This way, when the user enters A, the program outputs the actual letter A, not its number. While read reads just one character, readline reads the entire line until the enter key is pressed. It returns a string instead of a single character. This makes readline much more versatile. You can capture full names, sentences, numbers, or any complete input typed by the user. Here's a more practical example. We ask the user to enter their age. Readline captures the input as a string. Then we use inti.parse to convert it into an integer. After that, we increment the age by 1 and display the result. This example combines user input, type parsing, and output formatting, a mini-complete workflow. To break it down, write prompts the user, readline gets the typed text, int.parse transforms that text into a number. We increment that number, and writeline outputs the new value. Understanding this chain is crucial for building interactive console programs. Another useful method is readkey. Readkey waits for the user to press any key before continuing. It's often used to pause the program, for example at the end of a console application, so that the window doesn't close immediately. Simple but very practical. In real programs, users often input text, but we need to work with numbers. That's where the parse method comes in. Parse is a predefined static method available for numeric types like int, double, and decimal. It takes a string that represents a number and converts it into its actual numeric form. For example, if the user types 25, then int.parse 25 gives you the integer value 25 ready for calculations. This conversion is critical for processing user input safely and correctly. Let's look at a few examples. Int age equal int.parse 25 turns a string into an integer. Double value equal double.parse 3.14 turns a string into a double. Char letter equal char.parse a turns a string into a character. Bool is valid equal bool.parse true turns a string into a boolean. Remember, parse expects the string format to be valid. If the string isn't correctly formatted, C# will throw a format exception at runtime. So, always make sure your input is clean or use try-parse for safer error handling. Let's see a full working program example called square input value. First, the user is prompted to input a number. Readline captures it as a string. Double.parse safely converts it into a double. Then math.pow, a value, 2, calculates its square. Finally, the program outputs the squared result nicely formatted. Notice how reading input, parsing, calculating, and displaying are combined smoothly together, exactly how real-world console programs work.